Hello, class. In this lesson, we will discuss the process of the catalytic cracking absorption stabilization system. As we all know, gasoline is the fuel for gasoline engines. Diesel is the fuel for diesel engines. And lubricating oil can reduce friction and wear caused by contact between two objects. So, let's think. If these three are mixed together, can they still serve their respective purposes? Certainly not. Stones can be separated using a sieve to sort them by size. The operation of separating gas mixtures by utilizing differences in gas solubility in liquids is called absorption. If the equilibrium vapor pressure of a component in the solution is greater than its partial pressure in the gas mixture, then that component will be released from the solution, i.e., it transfers from the liquid phase to the gas phase. This situation is called desorption. Therefore, absorption and desorption can be used for gas-gas separation. In the fractionation tower, the reaction oil gas is separated into several products. For example, overhead gasoline and rich gas. Side streams yield light diesel and heavy diesel, and bottom products include slurry and recycled oil. Among these, the separation of overhead gasoline and rich gas is not complete. This portion will enter the absorption stabilization system to produce dry gas, liquefied petroleum gas, LPG, and stabilized gasoline. The purpose of absorption is to separate components below C2 from those C3 and above in the catalytic rich gas from the fractionation section, so they can be utilized separately. At the same time, a small amount of gaseous hydrocarbons mixed into the gasoline is separated out to reduce the vapor pressure of the gasoline and ensure product quality. In absorption operations, we often encounter two concepts, lean gas and rich gas. For catalytic cracking absorption-desorption units, gas generally containing more than 90% methane is called lean gas, also known here as dry gas. It is a gaseous hydrocarbon containing a large amount of methane and small amounts of ethane and propane. Gas with methane content below 90% and alkane content, such as ethane, propane, above 10% is called rich gas. In this unit, it is also termed wet gas. The composition of wet gas, besides methane, ethane, and propane, includes small amounts of volatile liquid hydrocarbons such as pentane, hexane up to octane. It may also contain small amounts of aromatic hydrocarbons and naphthenes. Figure 1 shows the dual tower absorption stabilization process flow. The equipment included are 1. Absorber, 2. Desorption tower, 3. Reabsorption tower, 4. Debutanizer, 5. Balance tank, 6. Condenser, 7. Heat exchanger, 8. Reboiler, 9. Reflux tank. Next, let's analyze this process flow. The function of the absorber and desorption tower is, in the absorption section, to use stabilized gasoline as the absorbent to absorb the C2, C3, and C4 components from the rich gas. Subsequently, in the desorption section, C2 components are desorbed and removed overhead as lean gas, mainly components heavier than C2. The function of the reabsorption tower is to absorb the gasoline entrained in the lean gas, with dry gas drawn from the top. It also absorbs gasoline from the diesel fraction. The function of the debutanizer is, under a pressure of 0.8 to 1 MPa, to fractionate the gasoline containing absorbed C3 and C4 components, producing qualified stabilized gasoline from the bottom. Overhead, it yields liquid hydrocarbons, mainly C3, C4, and gaseous hydrocarbons, mainly components lighter than C2. The stabilizer is essentially a fractionation tower, including rectifying and stripping sections. It is a multi-component distillation process where component fractionation and purification are completed inside the tower. The catalytic cracking debutanizer is a stabilizer, producing LPG from the top and stabilized gasoline from the bottom. The absorption stabilization system is an integrated system comprising multiple equipment such as the absorber, desorption tower, and stabilizer. From this, we can gain insight. When studying engineering problems, it is necessary to pay attention to the interconnections between things and consider problems with a comprehensive mindset. Alright, class, that concludes this lesson. See you in the next class.